Hudson here. We are back with chapter 22 now, dealing with our first unit in surface area and volume. Hopefully this chalk talk will be a little faster, but as always, please let me know if you have any questions or concerns, especially since I'm going to be moving quicker in this one. In our warm-up problem here, we see a very large cube. Let's call it like some art or something like that we're going to need to polish. And actually, if you go to Chicago, you're going to see the giant bean, which has a real name. But originally, it was made of all steel panels that were all welded together, and then it was polished, excuse me, polished to the point that you cannot see any of the seams. And you guys are going to learn about that before the Chicago trip here. But if we see that this little yellow square takes 10 minutes to polish, we get told that takes 10 minutes. How long would it take me to polish the entire thing? Well, we know that it's a cube, so one of the things that we can determine from a cube is that every length is going to be 5. So we could label all these if we want to see that all those edges are going to be 5. We also know that since it's a cube, all the faces are the same. So pause the video and take a second to figure out how long it would take you to polish the entire cube. Hopefully you paused the video and did this math on your own. But if I look at one face of this cube, that's a nice way to break it down, because since it's a cube, I know that I have 6 equal faces. So one face, I can calculate the area by 5 times 5 and see that it's actually 25 feet squared. I can also see that this yellow square that takes me 10 minutes is 1 foot squared, or 1 square foot. So I know that I can polish 1 square foot every 10 minutes. And then I need to see how much I have in total. Well, if one face is 25, I then take that 25 and multiply it by 6, because there are actually 6 identical faces on the cube. That gives me 150 feet squared as the total surface area of that cube. And I know that every foot squared is going to take me 10 minutes. So I'm going to multiply that by 10. And that is going to give me a total of 1,500 minutes that it would take me to polish that entire thing, which if I divide by, if I divide by 60, we get that this is 25 hours. So to convert from minutes to hours there, we just say there's 60 minutes in an hour, and that gets me to 25 hours. So if you did this nonstop and you were doing it alone, it would take you over an entire day, which is pretty crazy to think about. Moving on to our lateral area of the prism, I'm actually going to jump back over into digits and let this play out. Hopefully you can hear what it's talking about, but it does a really good job of showing you that the lateral area is only including the sides of the shape. It does not include the top or the bottom.
The lateral area of the prism is the total area of its lateral faces. Suppose the perimeter of the base is P and the height is H. You can unfold a prism to form a rectangle. Notice that the perimeter of the base of the prism is equal to the base of the rectangle, and that the heights are the same. The lateral area of the prism and the area of the rectangle are equal. So the lateral area of the prism equals the base of the rectangle times the height of the rectangle. Remember, the lateral area of a prism...
So what we're really doing here is taking all 4 of my sides of my prism, or 6 or 5 or 10 or however many prism sides we have, and instead of looking at them each individually, I'm going to look at them all together. So what I see here is I can kind of label these as like the left side, the back side, the right side, and then the front side. And instead of using sides, now we use faces. So we see that we have these 4 faces that make up all the kind of sides of my shape that go from the one base to the other base. So notice we're not including this face and we're not including this face. We're only including the faces that wrap around the shape. So that then is why we can use this perimeter, because it's the entire distance around, which is the same distance that we get from right here, and then just multiply by the height, since we're now looking at it as one large rectangle together. Now, where surface area changes a little bit is that the surface area now includes the lateral area and both of the bases. So now we are going to look at this as part of the area that I'm going to include. And I know that because it's a prism, This rectangle on top is going to be the exact same thing. So once I find one of those rectangles, I'm actually going to double it to count for both of them. So I could either add it to itself again or just multiply by 2, which is easier math. So once we find our lateral area, we just add 2 times the base area to get the total surface area. Now a cube is actually even easier. If I can get my screen to clear. There we go. A cube.
Suppose you have a cube.
Is easier because we know that all of the faces are identical. So just like we did in our warm-up problem, we want to think about if I find one face, which would be this length squared, I can then multiply by 6 to get all of them. Now I actually write this a little bit differently, and I say that surface area for a cube is 6 times the edge length squared. Now the only reason they use S for side instead of E for edge length is E is actually a mathematical constant. It has a value. We use it when dealing with certain interest formulas, but you guys will get to that later. So if you want to use E right now, that's fine, but you need to make sure that you remember it's edge length here, not the mathematical constant. So we just take whatever the edge length is, square it to find the area of one face, and then multiply by 6 to deal with the fact that we have 6 faces that are identical. Moving on to our actual practice problems. We want to find the area of all 3 of these, the total surface area, whether it's equal to 54 or not equal to 54, and we're going to go even further and say what is the specific surface area of each one. So remember, we're going to be using the formula where for lateral area we use perimeter times height. So with these prisms, it's easy. I can just choose the bottom face to be my base. But when we have like a triangular prism or a hexagonal prism, we always have to make sure that we choose the right base, which is told to us in the name of the prism. So here, if I look at my rectangular prism, I'm going to make that my base. So the first thing we think about is lateral area is going to be perimeter times height. Well, my perimeter around here is going to be the 9 plus 2 plus 9 plus 2. So when I think about the perimeter, I can really say, well, it's 2 times 9 plus 2 because I double my length and I double my width. So that's going to give me 22. My height is 3, so that gives me a total lateral area of 66. I'm going to go ahead and put that in a box because I'm going to use that. It has to plug into my formula. My base area, my big B, we always use big B to represent the area of the base. My base area is just going to be the area of that rectangle, which is going to be the 9 times the 2, which gives me 18. And again, I'm going to put that in a box because I'm going to use it. Because then I see that to find my surface area, I'm just going to go ahead and move this up here. To find my surface area, I use lateral area plus 2 times the big B, which my lateral area we found to be 66. My big B was 18, or again, that's the area of your base face. This becomes 66 plus 36, which actually when we do the math should come out to be 102, and I gotta have a label, so it's feet squared. Go ahead, pause the video, and try the other 3 shapes here to see if you can accurately find those surface areas. I'm actually probably going to stop the video here, maybe right now or maybe after I do one more, and then we'll pick it up in part 2 to finish up the rest of these notes. So pause the video, try this on your own. Hopefully you paused the video and did this prior to coming back. We see that we want to find the surface area of a cube here, which is going to be 6 times that edge length squared or that side length squared, but we like to call them edges now. So since I see that my edge length is 3, I'm going to square my 3. That becomes 6 times 9, which becomes a total surface area of 54 feet squared. Notice that because all of these are area, they're all going to be my units squared. Moving on to my next prism, again, any of these faces could be the base because all we know is that it's rectangular. So I'm just going to use the bottom face. This is going to be my base. It's also got easier numbers to work with. So we start by dealing with lateral area. Lateral area is going to be the perimeter times the height. So to do that, my perimeter is a 2 and a 3, another 3, and another 2. So I get 10 times the height, which is the distance between the bases. So that's 4.2 if I make it as a decimal, because 1/5 is a 0.2. That tells me that the lateral area is 42. So again, I'm going to put that in a box since I'm going to need that. My big B, my base area, is going to be that 3 times 2, which gives me 6. I can then plug it all into my surface area formula and say it's going to be my lateral area plus 2 times my big B. Do not forget that 2 times. That's where a lot of people make their mistake. They just forget to double that. 2 times 6 becomes 12. 12 plus 42 becomes 54 feet squared. So we see, even though this is a different dimensioned prism, we've got different length, width, height. It actually has the same width as the one before, but we see we can get the same surface area even though we made my prism differently. Now on my last prism over here, I'm again going to do the same thing. This actually kind of makes my life a little easy because 6 times 1 is going to be nice and easy. So first thing we want to do is lateral area is going to be perimeter times height. Sorry, smartboard's getting a little glitchy there. So perimeter around the base, well, 6 and 1 gives me 7. I double that and I get 14 times the height, distance between the bases, is 9. And 14 times 9, let's break it up. 9 times 10 gives me 90. And 9 times 4 gives me 36. So I have a total of 126. Again, I'm going to put that in a box since I'm going to use it. My big B, I'm just going to go ahead and write in here. Big B is going to be the 6 times 1. And actually, I'll shift this out. Can't really see the green in there. Big B is just going to be 7. So when I plug this all in, sorry, not 7. I added instead of multiplied. 6 times 1 is just 6. Surface area then is going to be my 126 lateral area plus 2 times my base area. This becomes 126 plus 12. We can see obviously it's not going to be 54, but it comes out to be 138 feet squared.
Are you talking to yourself again?